today, I mean, it looks like a lot. It really isn't. We're going to do geometric sequences, so you're multiplying or dividing between the terms, and then we're going to talk about the sums. I don't even know what's going on over there. Okay, and of course, we're going to do some stuff in our calculators. Now,
Courtney, wait for this.
Are we ready? Are we under control?
Wait.
Calculator, ready? All right, so we are, of course,
Got it out of my car.
you will see, quiet and listening, people, quiet and listening, pull it together here. You will see these geometric sequences come up, of course, in some real world applications. Finance is definitely one of them. There is a whole entire section on mathematical finance, which you see a lot of these formulas that are geometric sequences really popping up in there. So that's why it's good to take a look at some of these. So, now, I'm quick at multiplying. So here you can see, of course, they're dividing between the terms, which is totally fine. They're doing the second term over the first, third over the second. Of course, I'm quick at the multiplying. I just look to see what they're multiplying by from the first to the second, second to the third, so on and so forth. Now, yesterday you had the common difference on arithmetic. Today you have the common ratio. So just a different verbiage because, of course, different sequences. And obviously a different formula. So it's going to be the first term times your ratio to the n minus 1. So notice, because I'm going to use this today, you are multiplying by a ratio. So I put another one on it squared, cubed, fourth, so on and so forth. To go between the list of the terms, you're multiplying by the ratios. That's what we're going to be doing today. I'm quick at multiplying. All right, so determine whether or not it's geometric. If it is, find the ratio. So the question is, are you multiplying consistently by the same number every time? You might need your calculator to test it because you got some big numbers.
Yes.
Yeah.
What are you multiplying by?
4.
4. Perfect. So I'm going to say yes, it's geometric. Common ratio, 4. That's as wild as that gets. What about the next one?
No.
So if you're unsure, especially, you know, I like to sneak fractions and stuff sometimes at you. If you're unsure and you want to test it, because if you multiply, you would be doing it by a fraction, which I know how I feel about that. So this time I'm actually going to divide the terms. I'm going to do 19 over 4. I'm going to test that and see, does it equal, let's say, 34 over 19. So I just punch those in my calculator, see if you get the same thing. Do you? No. And you could test this one the same way. You could divide the terms. Like if I wanted to do 12 over 3, is that going to be the same as 48 over 12? Well, yes, you get 4 both times. I don't care how you figure it out, as long as you can tell me yes or no, and if it is, what the ratio is. All right, find the common ratio. So it's telling you it's geometric if there's a common ratio. The first term, the nth term, the 8th term, all the stuff here. Okay, so first off, what's the common ratio? 3. Multiplying by 3. Got it. It asks you, this is really kind of a dumb question. I don't even know why they put this on here. The first term. I guess I'll write it down. It's fine, yeah. Okay, the nth term. So now it wants you to get the formula. I think that's what it's leading you to here. So the formula, which again is on your purple sheet. It's the first one on my board over here under geometric. The first term times the ratio to the n minus 1. We've got everything we need. First term times the ratio, n minus 1. Now, careful here. Can you multiply the 5 and 3 together and make it 15 to the n minus 1? No. Order of operations. Order of operations is a big thing. Exponent first, so I can't. So I'm just going to leave it. And the reason, like yesterday, we like to get the formula. Now I can get you any term you asked me for. Well, they want the 8th term. So I'm going to put an 8 in. And you will get some large answers for some of these today because obviously when you multiply, they grow very quickly. So punch that in your calculator, you do get a big number. Yep.
Are you dumb?
Then I was doing it in my head.
Oh boy.
It would be nice to.
I was doing it in my head, right?
The look. I love the look. Any questions on how to punch that in your calculator? You don't have
learn how to.
Okay, Gail, you don't have to do it in your head, but I appreciate that. So easy enough, nothing crazy. Flip it. Find the indicated term. So they want the 22nd term. So I'm going to kind of like the last one. Obviously the first term's 4. what's your ratio this time? 2, we're multiplying by 2. So I don't know about you, I don't want to have to keep multiplying by 2 till I get to the 22nd term. That seems really obnoxious. So I'm going to get the formula, first term times the ratio, and then I'm just going to go ahead and find the 22nd term. Let's put a 22 in. So 4 times 2.
Okay, what is it? Go.
Oh boy. Kale, are you doing it in your head?
2 to the 21st. By like 20,000 size.
20,000, girl. You gotta go bigger than 20,000.
Really?
It's 2 million.
I forgot to add the zeros.
Okay.
Can we get a final answer? 4 times 2 to the 20.
14.
8,388,608.
Good work.
Oh, I already used to calculate.
I did that in my head.
Did it in her head. I like it. All right.
Don't
Any
worry.
questions on that guy?
That's fine.
Now, more of the same. You might be like, why are we doing more? Well, a little different here. We got to get a little ingenious about how we're going to get our R.
No.
So they skip terms. So I really don't love that they go from the first to the third. I want to know the ratio between each term. And of course, I had to throw you a fraction in one because, you know, I love a fraction. So I'm going to work on the R because I need that. Anytime we talk geometric sequences, R is where it's at. Like that is what's tying your terms together. So I'm going to divide the terms out because of the fraction. I'm going to go old school. I'm not going to be like, oh gosh, what are you multiplying by? I'm going to divide the higher term by the lower term, of course. Now, you can straight type that in your calculator, but I expect we can do some fraction work in our heads in here.
No, ma'am.
45 hours.
Oh boy. So this would be 5 over 1, so I'm going to multiply by the reciprocal,
Boom.
which is 45 over 20, but could we maybe reduce it?
9 over 4.
Yeah. Now, hold on a second. That's not R, because that is from the first to the third term. How many R's does that represent? 2. First to the second, second to the third. So this is what R squared is. Well, come on, that's not hard. How are you going to remember the squaring?
Yeah,
It could be bad later on.
3 over 2.
3 over 2.
I already said that.
I wasn't.
Now, not my final answer, but I just need that. You have some choices here, and I'm going to show you both ways. I never care how you do it as long as you can do it. I can do it just like the last problems, where I'm like, okay, I'm going to write the formula, the first term times the ratio, n minus 1. So now I need the 8. I'm already irritated with this. I feel like I could have done it faster.
I feel like this is a good way to shoot it.
So figure that out, and I would probably ask you for a fraction answer on that tomorrow's quiz. Just give it to me fraction style.
Oh, wait. 10,935 over 128.
Got it.
How did you just do that?
In her
In my
head.
head.
In her head. Alex, come on. Now, here's the thing, okay.
I can't add 6 plus
So
6.
that is, like the book way. The book way. I was kind of irritated after the first step writing this stuff out because I could have done it quicker for you. So I'm going to show you. Now, from the third term to the 8th term, that's not that big of a gap to me, okay? So remember, just to show us here really quick, remember our arithmetic or our geometric sequences, you're multiplying by the R's as you go through the sequence. So personally, I think I could have done it faster if I would have just taken my third term here, where we left off, times R. Our R was 3/2, but hold on. From the third to the 8th term, how many R's would that be? 5. If you type that green in, you get the same answer.
Oh. So why didn't you just tell us that before?
I think it's quicker. So some like the
The
rules and the formulas in the book way. Mrs. Pryor likes to work smarter, not harder, and she does the green.
5 plus 5 is
I don't care how you do it, as long as you get it.
45.
Okay? You pick your call. All right, let's do the next one. See what we got here. Okay, same deal. We don't have R. So it's all about the R. Start with dividing your terms. So I'm going to start with the higher term. You know I love a fraction over the lower term. And if you like it fraction style, can we divide that out without our calculators? Oh, Lord.
We know everything.
So I'm going to multiply by the reciprocal. So So 64 and 8, of course, reduces. So you've got negative 8 over 27. Now, that is not R. That's just the quotient between our two given terms. From the second to the fifth term, that's how many R's? R cubed. So how are you going to get rid of the cubing? Cube root them. And there is a cube root function, remember, in your calculator on your math menu, if you're not great at cube rooting in your head. What's the cube root of negative 8? Got it. So I'm just going to kind of circle that. Now, I kind of showed you my pro tip on the last one. That's why I'm going to do this one. Work smarter. I'm not going to do the formula. I'm going to take my last term they gave me. I'm going to multiply it by a ratio. And I'm asking myself from the 5th to the 6th, how many ratios do you need? 1. Is it worth me writing to the first power and the negative 2/3? No, I'm not going to do it. So I'm just going to multiply that out, and that's going to be my answer. Negative in our heads. 28 over 81. Now, you could have done the formula like the last one and plugged in 6 for n and done all the work, totally legit. But I like to just take the last term they gave me and figure out how many more r's we need. I think it's quicker. That's how I roll. Okay, let's get into the sums. Now, notice on your formula sheet you have two different sum formulas on there. There is the formula for what we call a finite sequence, a limited amount of terms, like the sum of the first 20 terms. And then clearly this little infinity symbol is going to be the one for an infinite sequence that goes on forever and a day. So just make sure you're reading closely so you use the right formula. So finite sequence, limited terms. Now, notice you have our formula. Here they're using I instead of n, big deal. First term times r to the I minus 1. And you can calculate it with this very lovely formula on the right side. I'm going to show you both. I'm going to do it what I call kind of by hand on the right. This you can pop into your calculator in Math 0. I'm going to show you both today. All right, so find the following partial sum of the geometric sequence. So to find our sum, some information we're going to need, of course, the first term, obvious. What's your ratio? Why am I putting A? How about R? Multiplying by 4. Now, here's the glitch, because of course there's always a glitch. Because this dot, dot, dot is messing with our minds. I don't know how many terms right now are in the sequence. And that's what I need to figure out so I know how many terms I'm doing the sum of. Okay, so we've got some choices here on how we're going to go about that. So I'm thinking about my formula. First term. So I'm sitting here thinking to myself, I don't want to necessarily guess and check and plug in like 10 or whatever. You can guess and check, it's totally legit. Just to remind you too, you can have your calculator do it. So go to y equals, I don't know, I got junk in there from who knows what. And I'm going to use x according, I'm not going to put the 1 times, okay? I'm going to put 4 to the n minus 1, or x in my case. And then pull up my table. And I'm looking for 4,096. I gotta scroll up. I don't know. I was doing other stuff in there. There you can see the 4,096. It is which term? The 7th term. Okay. So I'm gonna put a little note. That's my 7th term. And just FYI, I got that from the table and my graphing calculator. Now I'm ready to actually do my sum formula here. Now, because I don't want to go through and find the middle terms and like add them all together, that just seems obnoxious. I'm going to use my formula. So the sum of the first 7 terms, now that we know that's the 7th. So looking at my formula, it's the first term, which ours is 1. That's really worth it, but we're going to put it down. 1 minus r. R we figured out was 4. And then of course, n, how many terms we're doing the sum of? Over 1 minus r. So if you type the green into your calculator, which I'm going to give you a minute to do, that will give you the sum of those first 7 terms. So you can punch that in. You get kind of a big number.
5,461.
Perfect. Now, the other thing I'm going to show you too on this, okay? And you know, I like to show you some little tricks and stuff. So sometimes I might say, hey, you show work, use your formula sheet. That's what I need in green. Let's say though, because we're going to talk about the next one. Let's say your R was like some gross fraction, there's some negatives. You're worried about typing it in your calculator right. Don't forget you have math 0. You could hit math 0 and punch that sucker in, and it will give you the 5,461. So, if I say, hey, show work, I want the formula, I need that set up, am I going to know if you actually punch in your calculator the green or the blue? I'm not going to know what you type in the calculator. I'm just going to know that you're going to get the 5,461. So if you're worried about typing that green one in, especially if they give you some gross fractions and negatives and something sick like that, you can always do math 0 and check it. Now, you could do math 0 on this. Okay. Try that first. You're going to get a decimal. And
Oh, I did it.
I'm very literal when I say math 0. So punch it in. What do you got? Kale, are you doing it in your head?
646.8054.
Okay. All right, let's go 646. How about 0.81? Now, what if? Did we not get that? Oh, Lord. Okay.
I don't know how to do it.
So let me quit at it. So I am like super literal when I am saying math 0. Math 0.
That's what I did, but like, I don't think I typed
Okay.
it in right.
Well, probably not. Okay, I'm going to use x. X is 0. I forgot what the numbers are. That's what I'm looking at. Where are we? 15? For the top? Yeah, 15. Okay. Now, it might be your use of parentheses here. So 10. Now, they automatically put the one set of parentheses in. I'm putting the ones in for mine. What are we? 7, 6? So I like the alpha y equals.
Oh, raised to that. I should have messed up. Oh, that's raised. That's really stupid.
There we go. Okay, we're good?
Yeah, we just did raise that. What was that? Oh my. Why doesn't rounding?
I'll have to look at your mode. It's probably something in your mode that I can fix.
Jackson, are you
Now,
kidding?
oh Lord. Now, focus. If I say on a quiz, and you know I'm super specific in directions, use your graphing calculator, find this out. Bam, I'm done. If I'm super nasty to you and say, use your formula sheet, must show work. You have to be able to set up that formula over there on the sheet. So I'm going to set it up for us too. All right, this is going to be a fun question. I'm ready. How many terms are there from 0 to 15? 16. You're including 1 to 15 is 15. 0 to 15 is 16.
I told it was at 15.
Let me put that up. All right. Let me put my 16. All right. First term, 10. Now, let me ask you this. Which is easier to type in the calculator? The blue or the green?
Definitely blue.
They both kind of suck, right? But clearly the blue would be easier. But if I say show work, I need you to set this up. Am I going to actually physically know which one you type in the calculator?
No.
Sure not, sure not. But just make sure you can physically set up the formula if I ask you to set it up.
Literally.
I don't know what you put in your calculator. That's up to you and the calculator gods, okay? That's your call. Any questions on that guy? And our calculator, Jackson, I'll look at yours.
No, I found out.
Okay, good deal. All right.
No.
Oh boy. Use summation notation. What does that mean?
Summations, AP World. What? You agree?
It's out of my area of expertise. Summation notation, what do I
I
need?
wrote all those by myself. So.
It would be
Summation notation.
it's the, is it like the,
So weird.
these things.
They're doing it.
Yeah.
The E
The
thing.
sigma, the E
Yeah.
thing.
Oh, Patrick Bateman.
This thing right here on the paper.
That's Patrick Bateman right there.
Okay. Now, we're going to use our formula, okay? So easy question, what's the first term?
7.
I'm not writing A1 equals 7. What's your R? 2. We're multiplying by 2. Now, I'm going to use N, of course. What the heck term is 896?
Big one.
700.
Grayson guesses 700.
I don't think.
Wait, give me a second.
I need exact answers, people.
Wait, give me a sec.
No, you can calculate
It's
it.
using this formula, I think. I don't know why, but yeah. Is that 128?
So you could guess and check.
Alright.
Oh, it's
Is that
8.
128?
Is what?
Is that 128?
The 896 is the 128th
It's
term,
the
you think?
8th term.
By 7.
It's the 8th term.
Oh, no. My bad.
So Avery said 8th term,
Is it not?
which is, no, you're right.
Okay.
How did you get that?
I just multiplied it by 2.
So she's just multiplying. Now, again, if I'm in, let's put an 8 here. If I'm in a
smarter than me.
if I'm in a super mean mood and that's like the 29th
We're
term,
going to 29.
we're gonna do it in our table.
That's what I did.
Table. We're gonna punch it in our table and look for that in the table. In the table. Do you need me to do the table?
But I think
We got
my
it.
way was kind of bad.
All right.
No, it was already set up.
Notice it just says to write the sum. It doesn't actually ask you to find the sum. It just says to write the sum. Okay. So you don't have to do anything. Okay. Infinite. Let's talk infinite. Home stretch, my friends. Here we go. Our geometric sequence. Now, obviously, there's an infinity symbol for the infinite, or the dot 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 at the end, meaning that it goes on forever. So, what meaning can we attach to the sum of infinitely many numbers? It seems at first it's not possible to add infinitely many numbers. Just think about that. I'm going to add infinite amount of numbers and get a definitive answer. Okay, maybe. I don't know. We'll see. But we're going to take a look at the following problem. I don't know why I picked cake, because now I'm going to be hungry for cake here. Okay, you have a cake. You want to eat it by first eating half the cake, then eating half of what remains, then eting half of what remains.
You're starting off eating half?
Because you're on a diet. Well, you're hungry at first, Avery. I don't know. You're carb
I
loading.
need a whole cake.
Yeah, I know you.
The process can continue indefinitely. Oh my gosh. So you eat half. Focus, people, focus. You eat another half of that, half of that, half of that. So eventually we can get it down to a pretty consistent number, so to speak. So here's a little vocab for us. If the sum gets close to a finite number, like a third, like yesterday, we say it converges. If, of course, it doesn't, it diverges. So converges, we can get a number like a third, like yesterday, that 0.3 repeating. Sometimes that just doesn't happen. We can't make it work. So if our series, of course, is infinite, we have this very lovely formula. Now, here's the yuck part. You can't use math 0 for these.
No.
I know, the horror of it. Because you can't type an infinity symbol into your calculator. You are going to have to use this, but I mean, that's a pretty easy formula. First term 1 minus r. It's not going to take long. Yeah. Now,
Can you use that for like, even if it's not infinite?
only on infinite that works. Only on infinite. Okay, catch this note at the bottom too. If the absolute value of r is 1 or more, you can't get a sum. Because again, you won't get it close to a number like 0.3 repeating like we did yesterday. I just can't get it to some sort of number we recognize. So that is where you would have your diverges sequence. So let's take a look here. All right, find the sum of the infinite series if possible. All right, first question for you. What's r?
0.
R.
Oh, wait.
1/2.
1/2. Okay, so absolute value of a half, of course, is not over 1, yada, yada, we can do it. So I'm going to use my infinite formula.
Infinity.
Owen already said r was a half, so I'm going to fill that part in. What's your first term?
What's that?
0.
That's 1. If you put 0 in per n, what's a half to 0?
1.
Or really, what's in front of this? A 1. Because remember, the first value in front of r, which is a 1, why are we going to write a 1? Okay, really a 1 there. Or you can put the lower limit in and calculate. Okay, what's 1 over a half?
2.
2.
This one's not possible. Or this is divergent.
All right, what do we think it'd be?
It's divergent.
Okay, why? You're right. We can't do it. Why?
Because it's over 1.
It's over 1. So you say not possible. You can say it diverges. I don't care.
I say it divergent.
If on your quiz I asked for an explanation.
Bigger than 1. R is greater than 1.
Oh,
It's just an if or a when.
Because R.
It's
I
a
got it.
maybe.
If R is greater than 1,
You obviously
then
did it
And
wrong. It's not
that's
possible.
right on your formula sheet too. Okay, final one here. We can do it. Now the dot 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 means infinite. So first thing, of course, everything hinges off R this lesson. I need to figure out what R is so I know if I can even do it before I waste my time. What's R?
is it like,
Is it like times 3/4 or something?
Did you just guess that or did you know that?
No, I mean 6 is 3/4 of 8. So.
You are right. So you're multiplying by 3/4 every time, or if you hate fractions, divide them. 6 over 8.
I was like in the number range.
So can you do it first off?
Yeah.
Yes. R is less than, it's not over 1, we can do it. So my sum formula, the first term, well that's easy, over 1 minus R. Without a calculator, what's 1 minus 3/4? 1/4. What's 8 without a calculator? 8 divided by 1.
32. I said 32 first. I wanted to point it out. 32.
32. All right. Any questions on that?
No.
So it's very simple. Yeah, I know it's a lot of calculations and formulas, but nothing too crazy. At least I don't think.